Welcome students. Today we are going to see how to solve system of linear equations using matrix inversion method. Previously we have seen how to solve the system of linear equations using Cramer's rule. Okay, Cramer's rule we have seen. Now another method how to solve the system of linear equations using matrix inversion method. Okay, so the name itself says matrix inversion. So matrix inversion means inverse of a matrix, A inverse, B inverse, like that. So you know how to find inversion, how to find inverse of a matrix. Previously we learned. Okay, so it is very simple. So you know how to find the inverse of any matrix, so you can easily do this problem, right? So first what you have to see, Ax is equal to B. And what is Ax is equal to B? A, X and B are three matrices. Okay, A is a matrix, X is a matrix and B is also a matrix. Okay, right. Now what is A? Means A is a matrix consists of coefficients of X, Y and Z. And what is X means? X is unknown variables X, Y and Z, which is supposed to be written in column form. It's a column matrix. And B is also a column matrix, consists of constants. Right. Now you have to write the given system of linear equations in Ax is equal to B format. Okay. Right. Then what you have to do is you have to find the value of this unknown X. So you know already, to remove this A we have to pre-multiply by A inverse on both sides. So I have done that, pre-multiplying by A inverse on both sides of this equation. So A inverse into A into X, which is equal to A inverse into B. So A inverse into A is nothing but I into X, which is equal to A inverse into B. So I into X is just X only. So X is equal to A inverse B. We can simply say like that, Ax is equal to B. So X is equal to, bring this A here, it becomes A inverse B. Okay. Now we'll get into the problem. Exercise 1.3, sum number 1, subdivision 2. Subdivision 2, you are given two equations with two unknown X and Y. So 2x minus y is equal to 8, 3x plus 2y is equal to minus 2. So where X and Y are unknown. So first we have to write A matrix. A matrix is nothing but coefficients of X and Y. Coefficient of X is what? 2 and 3. So 2 and 3. Coefficient of Y is what? Minus 1 and 2. So minus 1 and 2. This is A matrix. Then X matrix is X and Y. The unknown should be written in column form. Then B matrix is the constant which is given on the right hand side after the equal to. So 8 and minus 2. Right. Now we have to find A inverse. So A inverse is equal to 1 by determinant A into adjoint A. So first we have to find determinant A. So write this A matrix in determinant form. 2 into 2 is 4, minus 3 into minus 1 is minus 3. So minus into minus plus 3. So 4 plus 3 is equal to 7, which is not equal to 0. A inverse exists. Now we have to find A inverse. The formula is what? 1 by determinant A. So 1 by 7 into adjoint A. How will you write adjoint A? Just interchange the two elements. So 2 and 2. Change the sign of minus 1 is 1. Change the sign of 3 is minus 3. So this is A inverse. Now X. X is equal to A inverse into B. So A inverse is this matrix and B matrix is this is written. Now we have to multiply and find the value of X. Okay. Now you know that X is nothing but a matrix of X and Y variables, right? Now here we have to multiply the two elements. So how will you multiply? 2 into 8 is 16, 1 into minus 2 is minus 2, minus 3 into 8 is minus 24, 2 into minus 2 is minus 4. So 16 minus 2 is 14, minus 24 minus 4 is minus 28. So we can take 7 from this matrix, isn't it? So I have taken 7 outside. So this becomes 2 and this becomes minus 4. 7 and 7 cancel. So we have got the matrix of elements 2 and minus 4. So X is 2 and Y is minus 4. Therefore X is equal to 2 and Y is equal to minus 4. Exercise 1.3, sum number 1, subdivision 3. Here, 3 equations are given with 3 unknowns x, y and z. Okay, so now we have to find the same procedure will be followed here also. So what is the solution? First we have to write Ax is equal to B. So A matrix is what? Nothing but the matrix consists of coefficients of x, y and z. So coefficients of x is what? 2, 1, 3. So 2, 1, 3. Coefficient of y is 3, 1, minus 1. So 3, 1, minus 1. Coefficient of z is minus 1, 1 and minus 1. So minus 1, 1 and minus 1. This is nothing but unknown variables x, y and z, and this is the constant term 9, 9 minus 1. Okay, so now we have to find what? X is equal to A inverse B. For that we have to find A inverse. Now A inverse is equal to 1 by determinant A into adjoint A. So first we have to find determinant A. So determinant A, just change this matrix into determinant and find the value. Now 2 into, leave the row 1 column, 1 into minus 1 is minus 1, minus 1 into 1 is minus 1. Since there is a minus, it is plus 1. And change the sign of this element, which is minus 3. Leave the row 1 column, 1 into minus 1 is minus 1, minus 1 into 3 is 3. Third element minus 1, leave the row 1 column, 1 into minus 1 is minus 1, minus 1 into 3 is 3. Okay, now minus 1 plus 1 is 0, so 2 into 0, minus 1 minus 3 is minus 4, so 3 into minus 4, minus 1 minus 3 is minus 4, so 1 into minus 4. So 2 into 0 is 0, minus 3 into minus 4 is 12, minus 1 into minus 4 is plus 4. So 12 plus 4 is equal to 16, which is not equal to 0, so A inverse exists. Now we have to find adjoint of A. So how will you find adjoint of A? So you know how to write it, like plus minus plus minus plus minus plus minus plus. Put the sign first, then the same procedure will be followed. Leave the row and element, row and column. You will be having 1 into minus 1 is minus 1, minus 1 into 1 is minus 1, therefore plus 1. Second element, leave the row and column, 1 into minus 1 is minus 1, minus 3 into 1 is minus 3. Third element, leave the row and column, 1 into minus 1 is minus 1, minus 3 into 1 is minus 3. Now second row first element, leave this row and column, you have 3 into minus 1 is minus 3, minus 1 to minus 1 is plus 1. Then the middle element, leave the row and column, 2 into minus 1 is minus 2, minus 3 into minus 3 is minus 3, so plus 3. Then third element, leave this row and column, 2 into minus 1 is minus 2, minus 3 into 3 is minus 9. Then the third row first element is 3, leave the row and column, 3 into 1 is 3, minus 1 into minus 1 is minus 1, therefore it is plus 1. Second element, leave the row and column, 2 into 1 is 2, minus 1 into minus 1 is minus 1, therefore plus 1. And the last element, leave this row and column, 2 into 1 is 2, minus 1 into 3 is minus 3 and transpose. Now minus 1 plus 1 is 0 and minus 1 minus 3 is minus 4. So it's minus, it is plus 4. This is minus 4 and this is minus 4. Since minus, it is plus 4. This is 1 and this is minus 11. Since minus, it is 11, it's plus 11. 3 plus 1 is 4. This is 3. Since minus is minus 3. 2 minus 3 is minus 1. Transpose of the matrix 0, 4, 4, 4, 1, minus 3, minus 4, 11 and minus 1. So this is adjoint A. Now x is equal to what? 1 by determinant A into adjoint A into B, isn't it? So 1 by determinant A, which is already found, which is 16, and adjoint A is this matrix is written and this is B matrix. Now we have to multiply. 0 into 9 is 0, 4 into 9 is 36, 4 into minus 1 is minus 4. 4 into 9 is 36, 1 into 9 is 9, minus 3 into minus 1 is 3. Minus 4 into 9 is minus 36, 11 into 9 is 99, minus 1 into minus 1 is plus 1. So 36 minus 4 is 32, 36 plus 9 plus 3 is 48, and the minus 36 plus 99 plus 1 is 64. So here we can take 16 outside. So taking 16 outside, it becomes 2, 3 and 4. So we can cancel these two elements. So we have got x, y with z is nothing but 2, 3, 4. So the value of x is equal to 2, y is equal to 3 and z is equal to 4. Exercise 1.3, sum number 2. If A is equal to a 3 by 3 matrix, B is equal to a 3 by 3 matrix, find the products AB and BA. Hence, from that, okay, from this one we have to solve the given set of linear equations. Okay, 3 equations were given. So in this problem, you suppose not to solve using the matrix inversion method. You have to use a different form, like finding AB and finding BA. You will get some conclusion. From that conclusion, from that idea, you have to solve the given 3 equations. Okay, so this is little different, but it is very easy and very important problem also, right? So now we have to find AB. So A matrix is written, B matrix is also written. We have to multiply. Minus 5 into 1 is minus 5. 1 into 3 is 3. 3 into 2 is 6. Minus 5 into 1 is minus 5, 1 into 2 is 2, 3 into 1 is 3. Minus 5 into 2 is minus 10, 1 into 1 is 1, 3 into 3 is 9. 7 into 1 is 7, 1 into 3 is 3, minus 5 into 2 is minus 10. 7 into 1 is 7, 1 into 2 is 2, minus 5 into 1 is minus 5. 7 into 2 is 14, 1 into 1 is 1, minus 5 into 3 is minus 15. 1 into 1 is 1, minus 1 into 3 is minus 3, 1 into 2 is 2. 1 into 1 is 1, minus 1 into 2 is minus 2, 1 into 1 is 1. 1 into 2 is 2, minus 1 into 1 is minus 1, 1 into 3 is 3, right? Now, minus 5, 3, 6, which is 4, and these elements become 0, this is 0, this is 10 minus 10, 0, this is 7, this is 9 minus 5 is 4, this is 15 minus 15, 0, this is 3 minus 3, 0, this is 2 minus 2, 0, and this is 5 minus 1, which is 4. So from this I can take 4 outside, isn't it? From all the elements I can take 4 outside. So taking 4, I have gotten unit matrix 1 0 0 0 1 0 0 0 1. It's a unit matrix. So 4 into I. So from this I can say that product of AB, that is A matrix into B matrix, which is equal to 4i. AB which is equal to 4i. Now we are going to find BA, which is also asked in the question. So BA, so B matrix first and A matrix second. So 1 into 5 is minus 5 is minus 5, 1 into 7 is 7, 2 into 1 is 2. 1 into 1 is 1, 1 into 1 is 1, 2 into minus 1 is minus 2. 1 into 3 is 3, 1 into minus 5 is minus 5, 2 into 1 is 2. 3 into minus 5 is minus 15, 2 into 7 is 14, 1 into 1 is 1. 1 into 3 is 3, 2 into 3 is 2, 1 into minus 1 is minus 1. 3 into 3 is 9, 2 into minus 5 is minus 10, 1 into 1 is 1. 2 into minus 5 is minus 10, 1 into 7 is 7, 3 into 1 is 3. 1 into 2 into 1 is 2, 1 into 1 is 1, 3 into minus 1 is minus 3. 2 into 3 is 6, 1 into minus 5 is minus 5, 3 into 1 is 3. Okay, now here 9 minus 5 is 4, 2 minus 2 is 0, 5 minus 5 is 0, 15 minus 15 is 0, 5 minus 1 is 4, 10 minus 10 is 0, 10 minus 10 is 0, 3 minus 3 is 0, and 9 minus 5 is 4. So here also we can take 4 outside. So I am taking 4 outside. Again I have got a unit matrix 1 0 0 0 1 0 0 0 1. So I can write it as 4i. From here also I can say that BA is equal to 4i. So previously we have got that AB is also 4i. So I can write it AB is equal to BA, which is equal to 4i. Right. Now see here, we can say either AB is equal to 4i or BA is equal to 4i. Any two form you can take it. So the question, you are asked to solve this given system of linear equations. Okay. So this is the 3 equations given in the question. So I have written here, right? Now usually we will convert this given set of equation into this form, isn't it? That means taking the coefficient of x, y and z and to be written in a matrix like 1 3 2 here, 1 2 1 1 2 1, 2 1 3 2 1 3. So this is a matrix, and also unknowns is x, y and z, and the constant is 1 7 2. But usually we will have this as A. Here I put this as B. The reason is in the question A matrix and B matrix are already given, where this is nothing but B matrix which is already given in the question. Can you understand? This matrix is already given in the question, which is B matrix. So that is why I have taken this as B into X, which is equal to C. Okay. Can you understand? Simply I have taken this as C. That's all. Because already A and B are given in the question itself. Okay. This is B matrix. So I have taken this as C matrix. That's all. You can take as any variable. Now in the question you are asked to find this X unknown. So to take this B to the other side, it becomes B inverse into C. That means pre-multiplying by B inverse on both the sides, you have got X is equal to B inverse into C. Right? So this is simple. But you must not find B inverse using the matrix inversion method. Instead, you have to find the B inverse using what we have got so far, that is AB is equal to 4i or B is equal to 4i. Okay, I have taken AB is equal to 4i. Now to find B inverse, you see B is at the last. So I am going to post multiply. Suppose if I take BA is equal to 4i means I have to pre-multiply by B inverse because B is given at the first. Either you can take this or you can take this. So AB is equal to 4i. Since B is at the back, at the last, I'm going to multiply. Post multiply by B inverse on both the sides. So AB into B inverse, which is equal to 4i into B inverse. Okay. Now B inverse is nothing but I. So A into I, which is equal to 4 I into B inverse is B inverse. So A into I is equal to 4 into B inverse. Right. Now this 4 can be taken to the left side. So 4 when it comes to the left side, it becomes 1 by 4 into A, which is equal to B inverse. So now we have got B inverse. So to find B inverse, it's very simple. B inverse is nothing but 1 by 4 into A. So when you multiply A matrix into 1 by 4 means you will get B inverse. That's all. Now the formula X is equal to B inverse into C. B inverse is nothing but what? 1 by 4 into A. So I have written 1 by 4 into A matrix into C. So 1 by 4, A matrix is already given in the question. So A matrix is written and this C is also given here. So that is also written. Now we have to find the product. So minus 5 into 1 is minus 5, 1 into 7 is 7, 3 into 2 is 6. 1 into 7 is 7, 1 into 7 is 7, minus 5 into 2 is minus 10. 1 into 1 is 1, minus 1 into 7 is minus 7, 1 into 2 is 2. Okay. Now here you see this is minus 5 plus 7 plus 6, which is 8, 7 plus 7 minus 10, which is 4, 1 minus 7 plus 2, which is minus 4. So from this matrix I can take 4 outside. Okay. So I am going to take 4 outside. So 1 by 4 into 4, taking 4 outside, this matrix becomes 2, 1 and minus 1. 2, 1 and minus 1. So 4 and 4 will be cancelled. So what is X? This X is nothing but X, Y, Z matrix. So this is 2, 1 and minus 1. So therefore X got the value 2 and Y is 1 and Z is equal to minus 1. So X is equal to 2, Y is equal to 1 and Z is equal to minus 1. And that's all. Thank you.